have a code club. This week, we're going to learn about variable scope, sprite rotation styles, and how to do pen drawing. Open up another browser window and log on to Scratch so that you can follow along. Have fun and let's start coding. When you create a variable, or you create a list, you get an option for all sprites or for this sprite only. And what these options do is set the variable's scope. The scope of a variable tells what else is able to access that variable. If it's set to for all sprite, which is typically called the global scope, that means any other sprite or the stage is allowed to have code that changes that variable. If it's set to for this sprite only, which is called local scope, that means only the sprite that you're editing is allowed to change that variable. When you set a variable to be local using the for this sprite only option, other code, such as what would be in your stage, can still see it using the sensing operator that's variable of sprite 1. It can read what's in that variable still, but it is not able to set it. And you can see that if I go back to variables, I'm in the stage, I don't have an option of test local. But if I switch back to my Scratchcat sprite, now I have an option for test local, because I can set test local when I'm in the Scratchcat sprite because it's local. I added another variable that's a global variable up here, so that means for all sprites, and I called it test global. And I wanted to show you this because this is kind of the only way in Scratch to know whether a variable that you've added is local or global. You have to have it show on the screen, and it'll say sprite 1 in front of it if it's a local variable, and it won't say anything in front of it if it's a global variable. So you don't have to have it always on there, but if you need to know, you can turn on the variable and it'll tell you real quick whether it's global or local. I set up a small example here to help show the difference between global and local variables in use. So I have 3 Scratchcat sprites. And if you notice, I have one global variable called global1, and then in sprite 1, sprite 2, and sprite 3, I have a local variable called local1. So it's the same name, but because it's a local variable, it's different in each sprite. Looking at the code, in all 3 of the sprites, the first thing I do is set global1 and local1 to be the sprite name. So in sprite 3 they get set to sprite 3, in sprite 2 they get set to be sprite 2, and in sprite 1 they both get set to be sprite 1. Then I say what the current variable global1 and current variable local1 are set to. In sprite 2 and 3, after we say the global and local variable the first time, we just wait for a half a second and say it again. In sprite 1 though, we reset global1 to be reset in sprite 1, and we reset local1 to be reset in sprite 1. And then we re-say what global1 is and what local1 is. And what this will show us is that for each of the 3 sprites, they're all going to say the same thing for global1, but they'll say different things for local1. We'll run the code and see what happens. So we can see that for sprite 1, global is sprite 1 and local is sprite 1. For sprite 2, global is sprite 2 and local is sprite 2. And for sprite 3, global is sprite 3 and local is sprite 3. Now if we look, after it's done its reset in sprite 1, global is reset in sprite 1 in all 3 of the sprites. Because it's a global variable, when it gets changed in all 3 places. But the local variable in sprite 1 is set to reset in sprite 1. But in sprite 2, it's just set to sprite 2. In sprite 3, it's just set to sprite 3. A good reason you might want to use a local variable versus a global variable is, for example, if you have 3 different enemies on the screen and you want them to have 3 different speeds, you could have a local speed variable in each one that's set to a different thing for each of your enemies. In general, it's considered good programming practice to use local variables instead of using global variables, but you do whatever's comfortable for you. Another important thing to note is that if you're using clones, when you set a variable to be for this sprite only, it actually makes it so that it's for an individual clone only when you create clones. I'll show you an example of that now. You can see in this example I have 3 variables, clone ID, global random number, and random number. And if we look at what they are real quick, clone ID is a local variable, random number is a local variable, and global random number is a for all sprites global variable. In the code, when it starts up, it sets the random number and the global random number both to be 2 different random numbers. and then it creates two clones with clone IDs of 1 and 2. Then if we scroll down and look at the when I start as a clone, this is where it gets interesting. This first little if test just moves the two clones to be in different positions. Then it says the local random number and the global random number. Because the local random number hasn't been reset by the clone yet, it's going to use the random number that was chosen up here for both of the clones. Then it picks a new random number, and this is where each clone is going to get its own copy of this random number variable because it's local to the clone, and we'll get two different random numbers when it displays it the second time. I'll run the code here and we'll see what happens. So we have two clones. They both have local 7, global 3. Now it's reset, it's picked a new random number, and now this one has local 2, but global is still 3. This one has local as 5, and global is still 3. So you can see that that random number variable that was local to the clone changed in each clone separately, but the global number will stay the same no matter what. I'm not going to show an example of this, but I wanted to talk about it real quick. But there's another option here for when you create a variable called cloud variable. You may not be able to use this option yet. It's only available once you become a level of Scratcher on the Scratch website. Cloud variables store the variable up on Scratch's servers. That means it can be shared between anybody who has your project open. So if you have 3 different people using your game, they can share variables using cloud variables. This can be good for tracking things like high scores, or you can use it to track the username of the last person who viewed your project, or how many people have viewed your project. There's a lot of different things you can do with them, but they have some limitations. Right now, cloud variables can only store numbers, and you can only have 10 cloud variables per project. One last thing I wanted to show you about variables is some features of the variable display boxes that show up on the screen. First of all, remember that you can turn the variable display off and on using these checkboxes. But also, you have code blocks for show variable or hide variable. And when you run those code blocks, they make the variable show or hide. So it's something you can do from within your code. And the same thing with lists. You can show list or hide list. When you have a variable displayed on the screen, you have some options for what it will look like. By default, it shows you the variable name and the value. You can change it to be a large readout, and that shows you just the value. Or you can change it to be a slider, and that puts a slider up on the screen that allows the user to change the value if it's a number. The value can only go from 0 to 100 if you use this slider, but it's a unique interface that you could use if you need to. When you have the slider up on the screen, it's a way to let the user interact with your code, because any changes that the user makes up in the slider affect the actual code. So this is how you would use the variable within your code, and right now it's showing 51. If I move it down to 26 and rerun that section of code, it's showing 26. For the list box, the first thing you need to know is that this little equal sign down here lets you change the size of it to be as big or as small as you want. The plus sign lets you add items to your list. Every time you click it, it adds a new item. If you click on any list item, it lets you change its value. And a little X pops up over here that lets you delete an item from the list. One thing to note is that this list editor is only available in this user interface of Scratch. It's for you as the programmer to change things about your list. The user isn't able to interact with the list like that. They are able to interact with the slider for a variable though. We'll switch over to like the standard interface that a user would see for your game or program, whatever you're making, and you can see I can't change anything in this list here. I can't resize it, I can't add things to the list, but I can still change this slider and it will still affect what the variable looks like in my code. The next thing I want to talk about is the Sprite Rotation style, and that's something that you set in the motion category. There's a set rotation style block. And what the rotation style does is set what your sprite's costume does when you move your sprite in a certain direction. There are 3 options for the rotation style: left, right, don't rotate, or all around. All around is the default rotation style that all sprites get. Just as a reminder, the direction comes into play when you use the move steps option for a sprite. You can set the direction that it moves down here and it pops up a little box. Normally it's going to move to the right, which is 90 degrees, but you can set it to move down which is minus 180 degrees. You can set it to move left, which is minus 90 degrees, or you can set it to move up, which is 0 degrees. For the rotation styles, the all-around option, the default option, makes the sprite costumes point in the direction you specify, and the sprite moves in the direction you specify. The left-right option makes it so that if the direction is set between 0 and 180, the sprite costume does not change direction. If it's set between 0 and minus 180, the sprite costume mirrors itself on the y-axis, so left to right. The sprite still moves in the exact direction that you specified. If you set it to don't rotate, the sprite costume does not change direction no matter what, and the sprite will still move in the direction that you specify. It's easier to show these with an example, so I loaded up example 15, which does sprite rotations. I'm going to run the same code 3 times, but change the rotation style each time I run it so that you can see what the differences are. This code is very simple, and all it does is make the scratch cat move around on the screen. So first he points in direction 90, which makes him move to the right of the screen. Then he points in direction minus 90, which makes him move to the left of the screen. Then he points in direction 0, which makes him move to the top of the screen. Then he points in direction 180, which makes him go to the bottom of the screen. We'll start with the rotation style set to all around and see what that makes Scratch Cat's costume do. So you can see he moves to the right and he's pointed to the right. He moves to the left and he's pointed to the left. He moves up and he's pointed up. And he moves down and he's pointed down. Next, if we choose left, right, we'll see what happens. So first, he moves to the right and he's pointed to the right. Then he moves to the left and he's pointed left. Then he moves up and he's pointed right, and he moves down and he's pointed right. And that's because left-right is weird in that if it's between 0 and 180, it points him to the right. If it's between 0 and minus 180, it points him to the left. So that means 90 and 0 and 180 all make him point this way. Negative 90 makes him point this way. Last, we'll look at the don't rotate option. So now when he moves to the right, he points to the right. And when he moves to the left, he still points to the right. When he moves up, he still points to the right. And when he moves down, he still points to the right. It's because the don't rotate style makes it so the costume never rotates, it just changes the direction that he moves. The next topic for today is called pen drawing. And this is not in the normal set of blocks for Scratch. You have to go down to this add extension option and choose pen. And that'll add a new block type called pen. Pen drawing is a feature in Scratch that lets sprites draw shapes on the screen using code. The way it works is, as your sprite moves around on the screen using the motion command, so the move and the go-tos and the glides, any of those will make it draw on the screen if the pen is down using the pen down block. If the pen is up because you use the pen up block or it's just off by default, it's not going to draw anything. I set up a real simple example that just puts the pen down and moves Scratch Cat 150 steps. That's going to make him draw a line behind him as he moves. So he drew this greenish line behind him because he was moving with the pen down. There's several different blocks for interacting with the pen. The Erase All block will erase any pen drawings you have on the screen with this sprite. The Stamp block takes an image of the current costume of your sprite and stamps it onto the stage as an image. So it's not something you can interact with, it's just a picture, but it's a way to get the current state of the current costume of your sprite onto the backdrop. Here's an example where I just have Scratch Cat move 10 steps and every time it creates a stamp of it. So I have the original sprite here, but all of these are just images that are stamped onto the stage. You can also change the color and the size of the pen. The color works just like any other color chooser where you can choose the color, the saturation, or the brightness, or use an eyedropper to get a current color off of your stage. And the size, you just put a number in. So I have this set up, it's just going to draw a line that's this dark red color for a pen size of 20. And you can see Scratch Cat was way down over here, so he moved, but you see I have this nice thick 20 sized line, and it's that red color that I set. For the pen size and the color, you can also change the size from its current setting with the change pen size or the change pen color blocks. So you don't have to just set them to specific things. If they're already set to something that you know, you can change it by a specific amount and that'll make it something different. You may notice that the change pen color option also has a drop down here, and that actually lets you change the saturation, brightness, and transparency also, so you have really fine-grained controls over what the color of your pen looks like as it's drawing. This example of pen drawing is very simple. It's just a really simple paint program. It paints in one color and just follows your mouse around. So you can see it says, when the green flag is clicked, go to mouse X, mouse Y, put the pen down, and then forever go to mouse pointer. So it's just going to follow my mouse pointer around. So we go here. It follows my mouse pointer around and paints underneath of it because I have the pen down as I'm moving my mouse pointer around. This is another example of pen drawing where instead of having it follow my mouse around, I just have it bounce around on the screen to random positions. And it also sets the pen color initially to this green color, but then it calculates the distance to the mouse pointer and resets the pen color as the mouse pointer moves around and as the sprite moves around on the screen. And you can see my sprite here is just this little dot. It's not actually anything important. So it moves around, and as you can see, as it's moving around, it's changing the color and changing the direction. The direction is based off of the random numbers picked in the glide. The pen color is based on the distance to my mouse pointer, and you can see as I'm moving the pen around, the mouse pointer around, and as the pen moves around, it's changing the color of the drawing. The last thing I wanted to talk about this week is the timer blocks in the sensing category. The timer variable is reset to 0 every time the user clicks the green flag button for your project when it's running, or when you use the reset timer code block. And what the timer does is accurately counts every second that your program is running since the last time the timer was reset. And the accuracy is all the way down to decimal level. So you can see it's been going for 353 seconds and some level of decimal. If I click green flag again, it's going to reset it back to 0. Or if I click reset timer in my code, ran reset timer in my code, that's going to reset it back to 0 as well. A typical use of a timer block is if you have a game that's a racing game like Mario Kart, for example, where you have multiple users that are all racing against each other for the fastest time. Another one would be something like Super Mario Brothers, where you have to complete the level, and how fast you complete the level counts towards your score. In the events blocks, there's an event for when timer is greater than a number. And so that can be used to detect when the timer reaches a certain level and do something. So for example, if you have a game where the user is only allowed to do something for 35 seconds, you can do when timer greater than 35 and then end your game based on that time. One downside of timers is that you can only have one per project. There's ways to fake it using variables. If you go out and search for multiple scratch timers on the web, you'll be able to see some examples of people doing that. Alright, that's it for this week at Code Club. I hope you enjoyed it. Now go out and do some coding on your own. Have fun, and we'll see you next week.